All right, this is just a little brief presentation on another numbering system called hexadecimal. Hex for short, base 16 is what it's also called. But I want you to look at this chart right here on this side, right there. And you've got a decimal value here, and that decimal value, that's us counting, right? That's 1, 2, 3, that's what decimal is, right? And then here's your binary value of that, and a 0 is all zeros. And notice that the binary value is 2 sets of 4 bits, so 8 bits total. We're dealing with 8 bits, and with that 8 bits, we can represent quite a bit. All right, so when computers first got going, the memory restrictions were so awful that they had to try to think of ways that they could fit more into memory. And that's not all that hex does for us, but that's one of the reasons why they gravitated to it. So the decimal value of 0 is all zeros in binary, and it's a 0 in hex. A 1 is just the first bit set to a 1, and that's a 1. Well, let's go ahead and go down a ways until we hit, here's 9. And now we want to represent a 10. Now we have a problem with representing a 10. Representing a 10 is actually 2 characters. It's a 1 and it's a 0, right? That's what it is. And so we would have to use 2 sets of 8 bits in order to do that. We would have to take this 8 bits and that 8 bits, and that would equal a 10. But we could do it a little differently. We could, since we're dealing with 8s, right? What we could do is actually substitute a letter, right? So A actually is 10 in hexadecimal, and there's the binary equivalent. And that goes all the way down to 15. Now you may think to yourself, wait, 15, shouldn't this be 16? Well, yeah, it is, because we started with 0. So we started with 0, went all the way up to 9. That gives us 10 positions, and then up to 15, which gives us 16 positions. And that equals an F. So a hexadecimal value that you'll see will be a combination of numbers between 0 and 9, and then A, B, C, D, E, F. Now, the reason I'm mentioning this is because when you get into IP version 6, it uses a hexadecimal value to cram as much into that space as possible. A MAC address, a media access control address that's put onto a networking card, also is a hexadecimal value. And when we're referencing RAM, which I don't do because I don't program, but when we're referencing RAM and putting data into RAM, because we're dealing in those 8s, hexadecimal is used there a lot. So I was actually really surprised when I took a look at the Google cert, and they spent so much time on binary and actually having you convert binary. And I do believe that binary is important to understand. It's important to know that for the computer, everything breaks down to an on-off switch, right? It's an electronic device, on-off, on-off. And then they use logic gates and other things to make logic happen with these on-offs. And so everything has to come down to these zeros and ones. Everything has to. But we actually use this hexadecimal value more often. And when you go out and work someplace, it's much more common for you to have to deal with a hex number and just be aware that that's what it's doing than it will be to use binary. So I wanted to give a little further explanation on this is what hex is. You will see it, again, IP version 6. You will see it in memory locations, and you will see it also in MAC addresses. So that's hex. There's a bunch of stuff out there on the internet. So if you're looking for more information, you can definitely find it out there.